welcome to this tutorial. This is going to be a brief guide to a project life cycle for a typical final year project. Things to bear in mind when you are executing a final year project are the following things. That there are two main people involved in these projects. One is yourself, who is responsible pretty much entirely for the project, and also your supervisor. Now, the whole point of being a sole developer is that you have to do all the following things. So here I've just put a few things in that you need to do. So you are the coder, you're the designer, you're the tester, you do all the analysis, you effectively do pretty much most of the project management as well. If there's any assets or art required for your project, you're the artist, you're the art director, and lots of other tasks as well. In other words, these are difficult in the sense you're producing a medium-sized software project with only you as the person responsible for all these different tasks. So before moving on to discussing what's a good way to manage this and what's a good project life cycle to adopt, we're just going to have a brief look at the role of the supervisor as well. So here are just a few of the ways you may describe supervisor. One as a mentor, possibly a technical expert, maybe in the area of your project, which would be great if that's the case, but often it may not be the case and you may seek other people for some expertise. You also may see them as a project manager, that's someone who guides the project, sets out the tasks for the project. And so as we go on to discuss this software lifecycle that we may adapt for these types of projects, we will bear in mind and consider these things. But let's start from the beginning and just have a think about what exactly a life cycle means in this context. So your project starts with an idea, and the idea should end up as actually a paragraph, something you can write in a paragraph, which is actually a very clear statement of what your software is going to do and what problem it's actually going to solve. And it's quite important you can do this. I think it's very hard to start a project if you do not have a very clear statement of intent of what the software is going to do. So the life cycle then is taking your idea all the way to the product itself. So I've just depicted this here as a simple graphic which starts from your initial idea, and the bit we're going to explore is this section here and how best to execute this life cycle to be your final product. Okay, a good way to look at this is we can usefully analyse the stages of a typical software project, starting from the concept and the idea and the problem statement. So let's just explore this in the first instance. So our projects, we often see is breaking down into these three main phases. Now you'll notice I've not included testing here because an obvious thing to do would be somehow put testing right at the end of this implementation phase, but that would actually be a wrong placement for this idea of testing, and we'll do that in a minute. But we have this, after our concept, we have analysis phase. Now the analysis phase includes the elicitation of the requirements primarily, but it can also include what you call analysis diagrams, which can be UML, it can be other sorts of diagrams that help you to discover exactly what it is you are going to build. So let's just explore that then. So here in the analysis, the question we're actually asking is, what am I building? At this point, you generally are not too concerned, and probably shouldn't be concerned, with the how you're going to build it. If you tend to get too concerned with the how, that can often stifle your creativity and prevent you putting in requirements which otherwise would have found their way in which you can obviously subsequently turn out you can actually implement and achieve. So you try to separate your thinking out, not get too concerned about the how at this very early stage. Anyway, is just think about what exactly is it I'm building, because what you're trying to do here in a project of this nature, which is a relatively short life cycle, is it's a good idea to establish as many requirements as possible. And that doesn't mean you can't add requirements at a later phase, but we need to consider that carefully. So analysis, we're really thinking about the what am I building. Moving on to the design phase, this part is how am I building it. Okay, so we separate these two ideas out: analysis, requirement solicitation, what is it I need to build, and then the design is how am I building it. And this is also synonymous with documents such as analysis would be your requirements documentation, and design would be what you call a functional specification. So taking each by use case, which is a useful thing to do, taking each use case in turn and actually exploring how that is actually going to be built. And then finally, just looking at these three stages, we have implementation, of course. Now, implementation, primarily for obviously software engineering, computer science, generally means code. It may mean hardware, and it may mean something else for business information systems. But either way, it is the concrete implementation itself as a result of the analysis and then of the design phases. But you can see I've not talked about testing, and I've not lumped testing at the end of this process. And that's because we don't see testing happening at the end of a project life cycle, where of course testing does happen at the end of the project life cycle. We should very much see it as an ongoing process right from the beginning. So let's try and put this into this diagram. So here I've added testing to our life cycle. Now clearly you can see this testing here is indicating that testing begins right at the beginning. There will be a separate presentation on testing, but just to explain what we mean by this. So testing, there's also different types of testing, as you're probably aware of, but quite a lot of it is based on two ideas of validation and verification, which is quite simply put down into am I building the right product, and am I building the right thing is really about have I got my requirements right, in a sense, and then am I building the product right, which is the bit of the testing which is more focused on the implementation and the design side. Am I building it correctly? And there's testing involved in that, and there's other types of testing involving am I building the right product, which really means is it right in terms of the requirements. Now if we had a client, and you can sometimes see your supervisor as a sort of client, you have a requirement specification which should be meeting your client's needs. Now often in a project of an academic nature, you don't have an obvious client, and therefore there is some flexibility in this, apart from when you have those early conversations about your project with your supervisor. You'll tend to agree things, and you'll certainly agree the direction of the project and also the outcomes of the project and what you expect your project to be able to do. And this is an important phase of the project, that this is well established, because it's a way of tracing the success of the project. And I'll come on to mention a thing called a traceability matrix later on, which is a very good way of directly comparing what you set out to do in terms of your requirements documentation and what you actually achieved within your project. So anyway, a good way to think about testing is am I building the right product, and am I building the product right? So we're just going to spend a little bit more time on testing, just to run along this testing, this orange testing bar here along the life cycle, and let's explore what sort of testing may go on along here. Okay, let's try and drill down into some actual process now that you could adopt as well. So as regards testing at this analysis phase, a good thing to do is you simply test the requirements. Now what exactly that does mean, and what would be a good process for that. So you go away, you may speak to potential users, and you may do some introspection, and then you gather requirements, and then you write requirement statements is often the process that you adopt here. Now while you're analysing these requirements, and you may be sorting these requirements out into core requirements or essential requirements, and then you may have your kind of nice to have requirements and possibly future requirements. Sort of typically three categories here. It's very a good idea to get together with your supervisor at this stage and walk over. What I mean by this is I mean by paper or desk check these requirements one by one. And this is a sort of a sanity check that they make sense. A, that they're worded correctly, for example, so they're very, very clear, they're ambiguous, but also you're trying to identify from your initial analysis whether there's any missing requirements as well at this early stage. So what you can do then usefully in terms of testing is paper check, desk check, walk through the design. So walk through the initial analysis at this stage, and if you've produced any diagrams at this stage, such as domain models and so on, again, there is opportunity for you to sit down and walk through it, and that is effectively testing. That's exactly what you're doing. You're testing your requirements. Okay, so let's move on this idea then at some other phases of testing. Okay, design. What do we do here? Now, it's true to say that the reality is for many student projects in their final year, after the analysis, the design phase is often completely missed out, or a small amount of design is undertaken. So often a typical life cycle for a student project will go from here, and then it will go to here. And then what happens is something will get implemented, which may work well, it may not work well, but then what usually happens is that the student will then, in fact, reverse engineer the design. So what ends up being presented in a typical project report is a analysis, an implementation, and what we would call a reversed engineered design. So by the time you're presenting your chapter on design, it's just class diagrams which have been often generated from an IDE, or they are a representation of a code. Okay, representing your code it expresses the design you actually implemented, but it is not the expression of the design phase, which would really be this functional specification. And if we look at the as I described earlier, the how am I going to build it? Okay. So then, back to this design phase. How do we do this? This is probably one of the things that a lot of students find very difficult. But what you need to do at this stage is, again, you need to think about how you are going to build the requirements that you've specified. So a great way to do this, because it's a good way to link things up, is we can start to consider the use cases that we created in our analysis. So here I've put down a simple use case that's come out from our analysis of this system that we're building, and it's just simply to log in. Okay. When you're at this stage, what you've possibly done is you've got your requirement statement. You've also probably done some research on software frameworks, possibly. So you may or may not have made a decision. What's the best type of framework to use for this, and then you're going to try and justify, why maybe you're doing an enterprise application and you're considering using Java Enterprise. Perhaps you're using .NET. Perhaps you're building a mobile application, and you've made some choices between Android and iOS, for example. But if we just put this to one side for the moment, although it is important, it can be important at this phase, is how would we now go on to design this? Well, let's take a concrete example. Okay, so let's imagine this is a website, but it could equally be a login from a mobile application. Okay, how would I go about designing this? Well, one thing I might choose to do, which would be good, is I'm also going to be thinking about the type of software architecture and the software design patterns that I'm going to adopt. Okay, I'm not at all thinking about code at the moment. I'm just purely thinking about how am I going to make this work. Okay, so one thing I would probably start to explore is you may immediately put this in some sort of model view controller pattern. So that might be your first effort at this design. So all I've done here is do a typical design diagram that I might do, which is just showing the user acting through a view to some sort of controller, which is going to probably create a model which probably end up getting written down to a database or retrieve some information from a database. So it'd be a sort of typical scenario. So why would I do this? And what I'm stating here, I'm still not thinking about the code. I'm just now thinking about what's involved in designing this login. Now let's just look at each of these components in turn, and can we push the design further? Well, let's think about the view, which is here. Then I may want to actually consider what this really looks like, in which case I might start to actually do some designs of the GUI as well. So I may think, well, okay, now I've established I need to do this login. What's this going to look like? And then this would then either become part of the user interface design. It could be a wireframe. It could be quite detailed design. It could be quite crude design, which is just showing the navigation between various pages, or if it's within a mobile app, between various views, and so on. So, but I've got an aspect of something I can go away and design. Again, I'm not really considering code. I may be considering putting down quite realistic UI elements at this stage. So if I'm doing an iPhone application, for example, I'll probably get something that looks like the type of elements I might find on an iPhone. But again, I'm still not really considering code. I'm just pushing into the design. Let's just jump the controller for now and have a look at the model and see why this might be useful. Right, the model will represent a few things. It will, in this scenario, it's probably going to represent some information about the user. So therefore, this may be the user's name, it may be the password, it may be some other details. And that's probably at some stage going to get written down to a data table, or if we do some object relational mapping, it will somehow end up in a database probably. So why explore this now? Well, this is good because this is helping me build up my data tables. It's also building up all these models, these entities that I'm going to require, and I can now capture these. So I can not only just sort of capture this login process, I will now know something about the data in this process. I'll probably can have a good guess at the data types in this process. It gives me an idea on a table I will need, or some object I'll require that's going to act as a connection to my database as well. Okay. And now let's have a look at the controller. So in this case, I would be looking at, well, what is the workflow, or what is the process, therefore, that this controller has to do to achieve this particular use case, which in this term is login. Of course, I could just document this on this sequence diagram that I have here, which may be a little bit too simplistic. It's useful, but possibly too simplistic. But I may spawn that out to, if there's some complexity to it, to an activity diagram, for example. And so starting from this login use case, what I've managed to do, without any real consideration for the kind of how I'm going to actually code this thing, I've explored many things. I've explored the view, which may lead to separately looking at my user interface design. I've looked at the model part of it, so I've looked at in this case, what particular model might represent this login or represent the user. So I've usefully started to build up my data part of my application, and also that's enabled me to think how I'm going to make data connections, depending on our approach to this. But also I've thought of the sequence of things and how this actual login task might be achieved. Okay, so let's just park that for now, and then let's think about just how we then might test this. So, can we test this phase? Well, we can in a way. Well, we can definitely. What we can do is we can do similar to what we did in our analysis. We can simply walk through it and sanity check it. And you only need to do this once. You can just have a look what you've produced for each of your use cases, and then you can just walk through it one more time, if possible. Walk through it again. Walk through it with a supervisor, which is a great way of doing it. It's always good to have someone else having another look at what you've produced, just to make sure it makes sense and there's nothing missing. Okay, so once we have done this, what about the implementation, and how far do we go with designing? Do we design everything, all our use cases, and then we don't do anything, don't do any implementation until we have a complete functional specification? Yes, you could do that. That would be an approach, and it really depends on how quickly you could produce some design. But often it's difficult to do that, and you may want to begin some implementation early. Now, some of the reasons for starting implementation is you want to often eliminate risks, and risks to a project are often that you don't understand the framework that you're going to use, or the documentation is quite poor, or there's something that your requirements have that you really need to solve and sort out. I need to know, for example, if I had an iOS application, that I can consume this web service and take this JSON data and display it onto a table, and you may want to prove that's a possible thing before you move on, and I think that's okay. There's no problem with that. So in other words, what you can do is you can start, once you're in this design phase, is to push into some implementation, but the key word here is it must be managed. Okay, because another gotcha, if you like, that often causes problems with student projects is their very early implementation, as in the very first thing they build after they've done some consideration of analysis, ends up being the root of the project and drives the whole project, and it just grows and grows and grows. So we're trying to avoid that. We're trying to do it a bit more smartly, and we're trying to manage this life cycle of, once we've got some analysis, we produce some design, and then we do small implementation cycles, but we try to do them flexibly and carefully, because if we get something in our implementation early, often that can make it difficult to add other things later if we've not thought about it. And I'll give you an example of that. If I produce this logging page, I've done something, and then suddenly it's worked out I've needed some more data for it, or I've needed to do something else, then I've got to go back and reinvent it again effectively. So you've got to be a little bit careful with that, but the nature is that you'll want to begin implementation, so that's fine while you're doing this kind of functional specification, but you do have to manage this. Okay, so let's just to finish this part of the presentation, let's just think about implementation and testing there as well. Okay, I've just put a few things here relating to implementation. Now, clearly, thing I didn't mention when I was talking in this analysis phase here is, of course, there is a research section to this where you should be probably exploring a similar systems to your own, which helps you gather requirements, but it's likely you'll be exploring the type of software frameworks and architectures that suit the problem domain. And these are things you'll tend to plan to use then later on in your implementation. But before we begin implementation, one approach is we just code, we just sit down, particularly if we're unfamiliar with the framework. We may just sort of sit down and start coding, which is okay, but we do need to sort of think about things. So I'll put a few things down here. Number one would be frameworks. So with our frameworks, that's really deciding what are we going to do. Now, obviously, if we're building a mobile application, that may be a relatively simple choice. We may decide to go for three things. We may go for, well, we're going to just do an iOS application. It's going to target iPad or something. I'm going to use Android, or perhaps I'm going to do a web-based approach. So this refers to the frameworks part of it. The other thing would be then looking at, well, what sort of patterns am I going to use. Now, I've used a model view controller pattern here, and there's plenty of other software patterns. Why do we use software patterns? Because they help with reusable software, but often the framework that you adopt, it may be .NET, for example, you may be using Swift and Xcode or Android and Creator, or you may be doing PHP with CodeIgniter. These will have preferred patterns that you can read up on and understand and apply, and they're done this way to make your life easier. If a framework, particular frameworks for a particular application adopts a pattern, then you should also adapt that pattern. As I say, model view controller is an excellent way to sort of think about most software And so you would need to spend a bit of time researching that, and if there are patterns, alternate patterns and different ways to do things, then you would do the right thing, which would be to compare and contrast these things to justify why you've adopted a particular thing. So you may be looking at a web application, and what you've decided to do is you've decided to adopt Net for this particular reason. And then you've also decided to adopt a model view controller with MVC5 or whatever the latest version, and it's recommended that you do data connections in this way. You handle your views in this particular way, and you may store things in particular areas, which brings me on to kind of architecture and code organization as well. So I'll deal with architecture first, which is here. Now, architecture in this sense, really I'm referring to the sort of the physical layout of your software. So software often can be just sitting on a single machine, which is very rare nowadays, and I doubt you'll be building anything that's just in one place. Chances are it is distributed over some sort of architecture. This being a database here, and this being some sort of service here, and typically this would be a three-tier architecture of a web client, a web server, which is possibly offering some other services, and we may have web services coming in here, which is all attached to a database. So this is sort of your architecture consideration, and within the architecture consideration you would also be thinking about the organization of your code as well. And this is just literally how do I put it into folders, how do I package it up, and again coming back to the frameworks will have an approach. So these are things to consider when you're doing your implementation, which is quite different to just code. One of the issues you'll find if you just code, especially if you're using architectures and frameworks you're not familiar with, is you'll probably apply a pattern that you've done from before, and it may not be the right one. That would be typically the case if you just sat down and coded in Xcode for the iPhone, for example. You really have to spend a bit of time understanding how these things are done. Okay, so I'm going to clean this diagram up, and then we're going to talk a little bit more about testing at this implementation phase, and then finally we're going to go into how we then work all this into some sort of sensible life cycle for your project. Okay, right, so what we're going to move on to is once we've done some analysis and we've done some design and we may have begun some implementation, we can wrap that up as a phase. Okay, and we can then think of, well, how should we now proceed with this? And what I'm recommending here is we adapt what we call an iterative approach. So what I've got here, I have a box which says P1, and what I'm intending this to mean is this is our first prototype. Okay, so it's a prototype of our application, and let's have a look what that might mean. So what we've got here then is we're going to have got our first prototype, and we're going to iteratively build several of these. So this very first one is we're going to keep quite simple. So going on our previous example, from one of our use cases was to implement a login on this particular application. So what we may do for this prototype, and these generally it's very good idea to write these down, decide what it is you're going to do. In this case, I'm just going to do a couple of simple things. I'm going to implement my login. I'm going to deploy my database. Now I have to think, well, what does this mean, and how am I going to do this? So how would I approach this particular prototype? And this is where it's a very good idea to keep a separate logbook as well, which records the necessary process to do this. So in order to implement this login, which is going to be my first prototype, the first thing I might do, depending on how you're doing your design, is I might decide to deploy the database. Maybe the first thing, and I may have a table on the database because I've done my design before, so I've got an idea now of what the table should look like, because I did the due diligence of producing a design for this in the first place. So now I can deploy this. Maybe it's in Azure, maybe it's on some external service somewhere, but I deploy a database. Now I'm going to stop there, because before I want to then go ahead and code that, I have to now also, within my prototype planning, thinking about the test planning for my prototype as well. So let's just quickly do that. So I've just got a couple of things I'd probably like to test in this case, and there will be more, but it's just to give you an example. So I would stop and test at this phase, and I'll say, well, okay, if I'm going to deploy my database, I need to test my database. Now, I want to test my database independently of my user interface. Now, to put this simply, if I'll give you an example, if I was using a MySQL database, I've deployed a database on it, I would test it first, and I would not use my user interface to test it. I would either test it from a command line, or I'd use a tool to send some SQL down to it and get something back. And of course, you can see parallels in your own project of breaking testing up into these types of manageable chunks over these prototypes. I then would have some interest in testing the UI, and that may just simply mean, well, if I type something in, it behaves the way I expect, and also it gets to the endpoint, as into the service, intact, and there's no issues in it. I may do some testing and then realise that I've actually got to add some validation or verification to these text fields and so on. But my approach has been, I've specified a prototype, I've said what I'm going to achieve in the prototype. In this case, I'm just going to implement a login function, and I'm also going to do some testing of it. And the other thing is worth doing in this case is to do a kind of a bit of a black box, really. So, and just say, well, for this particular prototype, this is what's coming in and this is what's coming out. So in this case, I'm going to be giving some information, which is going to be a login, and the result is going to be that. And that way, I've demonstrated that I've achieved the correct functionality, and this again is a test case. The test case would something like a user puts in username and password, and we get the expected result out. Okay, so what we then do is we can either agree with your supervisor these small prototypes, and then we can move on to our next one. Okay, so this is prototype 2. Finished with prototype 1. Well, right now what do I do? Well, I simply increment the features, iteratively building the product. Okay, so let's just think of some further examples and explore this prototype 2. Okay, so I've just written a few things here. So now I've decided, now I've got my login working, I want to implement a bit of this which allows another use case I've got, which allows the user to change their details. And for this purpose, I will probably want to implement the data objects for this. Depending on how I'm doing it, I may want to create the user interface and so on. And again, I would have some sort of test plan as well. Okay, and the test plan would be very similar to prototype 1. I would probably want to test the database, test the UI, and test the thing works from the black box approach, which is effectively a system test, just to make sure the whole thing works. So as you can see with this approach, these are very close iterative cycles, so you probably creep a lot more features than I'm putting in here. You may try and implement 4 or 5 major things in each prototype, which means, or suggesting, that they may be some kind of, let me draw it again, that's not very good. You may get these sort of midway prototypes as well, which are transitioning between these kind of major ones, where you've just done a small feature creep, and you want to then show that to your supervisor, and then plan these sort of major prototypes, in my case, which are P1 and P2, and they would others that would follow from that. Now the question becomes, what happens now if, when you are reviewing these prototypes, you discover a requirement, which is very possible. So after this prototype 2, we've done something and we've discovered we have something missing that we didn't think about right at the beginning. And the advantage of this approach is that you are likely to do that, because that's quite natural, that as you actually get to see your code, your design concreted, things may come up that you missed early on. So how do we then handle this? Okay, well, it's not a problem. We've got to ask ourselves a question: what sort of requirement is it? We have to classify it again. Is it a core requirement? Is it something so important that we must go back to our design and we must put this in? or is it a nice to have? We've seen something and we thought that's a great feature. It'd be great if we can put it in. In that case, we can park it. But what do we do with this requirement at this stage? Well, what we should do is again do our due diligence with it. So what we're going to do with this requirement is we're going to do the analysis and some design as well, just as we described before. Okay, so this becomes an addition to our functional specification, which was our design document that we were trying to produce, which is great because until your project ends, you should always see requirements specification and design specification or functional specification as live documents. With the small caveat that these are only short projects, so you can't. It's a much better idea to capture as much of your requirements early on as possible because there isn't that much time to keep on cycling around this. But you should do that, and there is no issue to do that. We're not following. I'm not recommending a really linear kind of waterfall model where everything has to be specified up front. There is some room for you to also iterate back over the project from the requirements and to do the design. But what I do recommend is that when you do discover these things, that you make sure that you apply good managed process by looking at them properly and then feeding back into the design. And one of the reasons to do that is because if you suddenly introduce something without giving it proper consideration, it can effectively perturb what you're doing and introduce defects later on which get much harder to fix. So it's just to make sure if I've got something new to add in, if I introduce it, it's not going to have impact on other bits of my system, other bits of my code, and so on. But otherwise, it's absolutely no problem. You probably don't do too much of it, but if requirements suggest themselves as you're going through this process, then that's fine. We now have another prototype in here, P3, and essentially we are just repeating what we did for the first two prototypes. Agree, and I recommend you agree with this, your supervisor, is you agree what the next prototype is going to look like, and then you need to decide what functionality you're going to get into the prototype. Design your testing. Now that means design the testing prior before you do the build, which is a kind of good test-driven way to do projects anyway. So as the case is before, decide what features you're going to do and decide how you're going to test. You can even produce the tests as well, and do the due diligence of doing the implementation, doing the testing, looking, does it suggest any more requirements, and then go back and do the necessary work for that, and then gradually and iteratively creep your design and your implementation towards your final goal, which is going to be your end product, which is the thing that you're going to be vivid on at the end of your project. So just to summarise on this phase then, so once you've gone past your analysis and then you've done the design as I suggest you do it, you're moving on to this implementation by doing an iterative approach, by doing a number of prototypes. The prototypes you can agree with your supervisor as in what implementation, what would be sensible. Then you can test it and you can demonstrate it, and then you can move on to your next prototype. Now a question then becomes, well, how many prototypes do I do, or what's the length of time between doing these prototypes? And there's no easy answer to that because it really depends on the nature of your project. If you're doing a classic software project such as building a web application, it may be fairly easy to decide regular prototypes which say maybe occur every 2 or 3 weeks, or longer. Maybe you may do one a month or something for your project, and that's because the flow is reasonably easy. There aren't that many things to sort of problems to solve. It's all reasonably straightforward. But there will be times, of course, when you get to a bit of your project which is difficult, and that might be that it's just something that's quite complex to implement and that's taking more time than you thought, and then you may want to simply focus on that, and it may mean therefore there's quite a bit of time between one or two prototypes. Now, if you're doing a project which is maybe a bit more algorithmic in nature, it doesn't really matter. The approach still works. It's still a matter of sensibly splitting up your project into manageable chunks. And again, I've used the word again, managed. When you build software, it should be a managed life cycle. Okay, it shouldn't be just sitting down and coding and doing that sort of typical chaotic build. Okay. So just to summarise, let's look at some key recommendations. So it's a good idea when you begin your project, and there's an opportunity to do this in the early stage of the project, where you've got to focus on requirement solicitation and analysis, is try to get a complete set of requirements at the beginning. This does help, and it does save time later in these sorts of projects. So that means doing all the good things, which would be the requirement techniques that you're taught, interview, survey, introspection, and so on. And two, design and do functional specification prior to coding or the implementation. This is the phase, as I mentioned earlier, which is most neglected in student projects. As I say, they tend to jump from analysis right to coding, and then jump back to this phase, which is of course reverse engineering your design to present something in a report. This is a key phase in any serious software life cycle. It helps eliminate many risks, helps you design. It will enable you to have a far easier job of implementing your code, because you will not be trying to do things on the fly. You would have sat down and designed your data dictionary. You'll know what things look like. You'll also know the sequence of things, and if you've done the testing, which I'll come on to the next point, is you'll also have eliminated and prevented defects being propagated through your code, which would cost you in the end. So as I described earlier in this presentation, a good idea is to design by use case, and in which case you can attach, you've got your analysis for your use case diagram, which can drive into your design, which again you can tie to the use case, and then you can implement across the use case as well. So in a typical software project, it's actually sticking to this use case space, as it were. It gives you this traceability all the way through, as in you specify a use case, you design it, you implement it, and then you test over it as well. Three, testing is an ongoing process. As I've described, I've not even talked about testing at the end yet, because I've been referring to testing all the way through the project life cycle. So that's right from your requirements, and we talked about the paper checking and the desk walkthrough with your supervisor and the sanity checking, right through to testing your design, again walkthroughs and so on. And obviously you need to test code. Now, testing code isn't debugging, or that's kind of part of creating your code. So of course there are other strategies that are a bit outside the scope of this project to discuss, but you also need a strategy for code testing, which may include things like unit testing, for example, and auto generation of test cases. But the main thing to see is that testing is an ongoing process, right through the end, right to the end of your project, and you may end up with some final testing, if you like, which traditionally would be called user acceptance testing, where you may demonstrate a final thing to your supervisor. But of course, because you've been building to prototypes and iteratively building up your project, a lot of this is actually already done for you. So there shouldn't be any real need for this big bang set of tests right at the end, because you've been doing this all the way along. Though it is useful to do some final system testing where everything is actually glued together and working, and then you can again run a set of tests by use case for test the functionality of your application. So point there, testing is an ongoing process. It's not something that we just lump at the end of a project life cycle. Okay, and 4, we have build iterative prototypes. It's probably what you would naturally do, but the key thing here is that these are managed, and that's the thing. You need to manage these, and it's also a good idea to agree these with your supervisor. So usually, once you're getting into your implementation phase, you can sit down with your supervisor, and you can agree what you will bring to the table next time, which will be this incremental functions. You'll implement various functions incrementally and plan these prototypes, and crucially plan the testing of these prototypes as well. Number 5, we have while you're doing your prototypes, look out for new requirements. Obviously, they will probably just crop up from time to time, but try to make the effort to drive these through this analysis and design phases rather than just code them on the fly, because that's likely to have impact. And also, if you do introduce something that you think may have some impact, then do some regression testing, as in test things that you've tested previously to make sure that some bit of code or some chunk of functionality that you've added does not have any detrimental effect to other things. So don't worry about the new requirements, just drive them back through the cycle, through the analysis, through the design, and then into your implementation phases and into your prototypes. And finally, 6, it's quite important that in projects that you work steadily. So that would probably mean realistically allocating a number of hours a week, possibly at the same time, so you get into a pattern. Quite a thing that will cause projects problems often is if you neglect to do something for 1 or 2 weeks on the project, because it's very hard to pick things up again. You waste a lot of time trying to remember what it was you were doing. So again, a way to aid that would be to keep logbooks and a good record. And a logbook is something like a sort of project diary which you can use, and I strongly recommend this. And great use as well when you actually come to write your final project report as well, because a lot of them, again, if you've been doing due diligence on the design and the documenting things, then the project will hopefully pretty much write itself as well, and it saves that big bang at the end of suddenly having to write a lot of documentation, and it's a real struggle. So plan your time, plan activities. I always recommend that you, if you're testing, for example, for a period of time, only test. It's not a good idea to do a bit of implementation testing. Try to put a test hat on, and while you are testing, you are trying to break your code. You are doing that, going through that process of really testing your code properly. Likewise with coding and designing, try and sort of separate these activities out. So that's the sole activity you do for half a day, for example. And I've just added one more, 7, which very much like your implementation, is also iteratively build up your documentation as well. And what I mean by documentation, of course, is your project report. It's a absolutely crucial part of the project, just as important everything else you're doing. Some argue more so. So therefore, you do not want your project to suffer, because you do get cases where you've done a great implementation but you've got a very weak documentation, and they are seen as all part of the process, and often you treat the documentation as indeed no different to the software. You see them as one in the same thing in a software project. So very important. So how do you do that? If you do the analysis properly, and you take the trouble to do your functional specification and your design, you actually have already got your design chapters and you've already got your analysis chapters. Again, with the implementation, the chapters there tend to want you to sort of describe key features and how they were implemented, describing the code, discussing the issues, and so on. Use a logbook and make regular contributions. You can plan a document simply by having an outline of the document as well and showing that to your supervisor. So that might be outlaying the chapters and then just a few sentences describing what's going to go in this particular chapter or this subsection of this chapter. And again, a bit like you do the testing in the rest of the software lifecycle, you can walk through designs of your documentation and your project report as well. So it's a good idea to keep showing supervisors bits of your project report. Maybe not necessarily all the detail, but at least an outline of what it is you're going to produce, and again, iteratively creep the documentation along with your software as well. So by the end of when you're within a few weeks of submitting the work, then you're in a position to have a good product that you've been iteratively building and testing all the way along, but also you've got a document to go with that, and it will make life hopefully easier for you, and hopefully help you with to get the best outcome out of your final year project.